Welcome everyone to the big problems facing functional programming and a possible solution by Randall Ratsch. Randall, we're glad you could join us today. So with no further delays, over to you, Randall.
Thank you very much for coming. Thanks for coming. I've been trying to work on this for a little while, and hopefully you will enjoy it. It's been pretty cold up here. It's about 6 a.m. out in Massachusetts, minus 10 Celsius. I hope this will be something helpful for you. So let me just get right on into it. All right. Generally, I'd like to address a number of questions here. Who am I? What are the problems facing functional programming? Where's the general crisis in programming? Where's an opportunity? Is there some sort of killer app? Spoilers, it's to run everywhere. How can this be cost effective? How can it be easy to use? What's my feature wish list? Who could benefit? What's the end goal? And what are some samples? Generally, I would like to I have tons and tons of bullet points. I'd like to pound through them, but I am open to questions at the end of slides. So please chime in if I'm either moving too quickly or something is confusing. All right, moving on. Who I am. I'm Randall Ratsch. I'm 59 years old. I fell in love with programming at age 13 in 1978. It's the very beginning of personal computers. I was looking at TRS-80s and Radio Shack computers back then. Very interesting time. My first computer was an Apple II Plus with 48K. That's not MB. There had no lowercase and a cassette tape recorder instead of a floppy drive. I didn't really know that's a thing, and I haven't really seen it since. A bachelor's degree in computer science math from University of Rochester. In 1993, a fellow programmer and I quit our jobs and started a human resource database that we wanted to launch a company with. We're moving from MS-DOS to Windows, so that really tells you what the time frame is. The next year, we incorporated, moved to Boston. I met my lovely wife here. We were forced to rewrite the code many times, from Visual Basic to Java to active server pages to Java Web Services. We happened to catch the internet wave and built the company over the next 20 years to 100 employees and about the same number of contractors in India. Eventually, we sold the company. I retired, and here I am. My perspective is not really as a scientist or an engineer. It is as a programmer, an architect, a manager, a documenter, quality assurance, CTO, and a stakeholder. As a partial owner and CTO of the company, my general criteria was that things be manageable. P.S. I'm not selling anything here. My bias, I like big picture and abstraction, and I don't really like the nitty-gritties of efficiency or working toward the metal. I generally think those things are shifting sands, and I care little for them. Obviously, my opinions are not the only ones. I have a special call out here to Alexander Granin, who happens to be in this conference, who does a very comprehensive analysis of his own on the weaknesses of functional programming, and I refer you to that. It's a brilliant piece of work. Any questions? I doubt you would have them, but if not, I will move on. Problems facing functional programming. So there's a number of issues here, and I want to try to take these from different perspectives. So right off, functional programming is not mainstream. We know who the major languages are, and they're not functional. There's a handful of ones that are sort of pretending to be mainstream, but we know who the big players are. As a project, somebody running a project, it is obviously not a safe choice to choose a functional language. If you're putting money toward a project, you have to have a large team. you don't want to experiment. Therefore, a different language is not really something that you're very keen on taking. There's a general lack of jobs. Obviously, everyone here knows that it's hard to get paid writing functional programming. There's a lack of consolidation within the field. We don't speak the same language. You see a laundry list of languages through this conference, and I don't know many of them. There's a lack of libraries. So functional programming is not a language, it's more of a style. So each language has to reinvent the wheel, making their own libraries, and some of those fall into lack of support because they become too niche. There's a lack of education. Functional programming appeared at the dawn of programming, but it is rarely taught beyond programming theory. I happened to learn about it in a Lisp course that was actually just a AI course in college, and really it was a side effect of AI, ironically. There's lack of a killer app. There's no defining reason to use functional programming that is very clear. The field is generally shrinking. Functional languages are declining in use on various metrics. We have a core ideological problem, conflicts over what is pure, what is mathematical, what is the end goal for functional programming. If you make things too pure, nothing can happen. It becomes a read-only environment. There's a rise of AI. I think all of us are at least somewhat concerned about this. And AI training is a small point, is that AI is probably not being trained on the languages that we use. It's probably using one of the mainstreams. So it will be better at writing those, and this becomes a flywheel for more and more work. So that's generally the problem that I see in functional domain. Any questions? Sure. Python, maybe. Python's been around. I don't have a specific opinion on it. A general crisis in programming. So I see that there is a general problem happening in programming around the world. The big ones are the platform wars. We have all of these different major players, and you notice a distinct lack of overlap in the technologies that they use. They are largely attempting to own these environments, and it is complex. We have different web technologies. So if you've been working in web stacks, there's a laundry list of technologies that you have to use. These are languages in and of themselves, and they don't necessarily play very well together. They're certainly not very similar to each other. And of course, there's far more different components that you might use in a development environment. Chip wars, we have now many different manufacturers creating different technologies, and which would tend to move toward new languages or new efficiencies. Lack of backwards compatibility. We've got Windows not working very well on ARM. We've got different console generations. Generally, whenever there's a new thing that comes, backwards compatibility gets a hit. We have end of service problems. Our actual company had a big problem when Flash was removed, because we had a lot of investment in that, and all that had to be rewritten basically from scratch. You have licensing and transparency problems. You've got like the war between Oracle and Google over ownership of Java, and so you have Kotlin as an end result of that. Currently, you have a bunch of layoffs and wage reductions in the programming space among the big players. Choosing a language limits your job opportunities in the future. So if you choose to work on C#, suddenly you're a Windows programmer, and that's kind of it. And you can do shifts, but that is difficult, and it generally puts you on a track and limits you. On the reverse side, jobs require a specific language that limits candidates. So suddenly, as a hiring person, you have a very limited pool of those people who can support the language that you're using because of the complexity associated with and the lack of knowledge share. And therefore, you have to pay them more. So it's a very illogical combination. And of course, we have AI writing code, which is something that we don't really know what that even means. All right. Generally, this is unhealthy and unsustainable. The opportunity. So out of all of those problems, do we have a window of opportunity? Mainstream language have many flaws, null pointer exceptions, a vagary between pointers and class usage, inconsistent type hierarchies. There's weird collection handling, misuse of global variables, poor exception handling, lack of thread safety, poor testability. They promote side effects like hello world program is already returning void. It's something that we wouldn't do as functional programmers. Also very uncomfortable syntaxes are fairly common. So the platform wars hurt the industry. So each vendor pushing developers in their own walled garden dilutes the talent pool. The platform wars are intended to attempt to own language and bring development community into that language. It's very damaging to the development community and to product as a whole. Platforms are changing. So Intel used to dominate chips, but not anymore. Every tech firm is making silicon, and that is happening more and more. It just seems to be like there used to be a handful of silicon developers. Now everyone is a silicon developer. Projects with multiple platforms with different languages tend to lead to inconsistent outcomes. Anyone who's done app development knows the complexities of building out to a web version, to an iOS version, to an Android version, Windows version. How do you make these things all the same? They're all developed in different languages. How do you manage test? Very expensive. We see a steady movement toward parallelism and asynchronous code associated with RISC and GPUs. Intel losing their grip here is part of this. AI code puts more emphasis on readability, APIs, and testing. I would argue that if you're allowing AI to write code, the only thing you can really manage is how readable is the code that it generates. What are its APIs, and are they consistent with the last version? And what testing are you applying to those APIs? And if you're writing object-oriented code, God help you. Functional, simple function returning values of truth table and putting tests to that is at least something that is reasonably manageable. Generally, functional languages are easier to learn, and functional languages are easier to test and should be more stable, particularly in asynchronous environments because of increased thread safety on immutables. All right. Any questions? Moving on. The killer app I propose. In order to have a killer app, we have to do something that other languages don't do well in order to make there be a reason for functional programming to be a choice. It should have broad utility. So functional programming is already niche. We don't want that. I argue that we would need a common tongue here, a simple language that runs on whatever platform you have. So I'll get back to that in a second. Separate language from platform. Basically, my argument is that people are spending a great deal of money building platforms, technologies, and languages, and that functional programming should be more about a language above this. It is a style placed upon these technologies. So to use their languages as our launching point. So basically to create a new language that compiles to these languages and integrates with these languages. So complement other languages, replacing them is unrealistic, and that working with them will make them better. To generate native code. So if we have a simple code language maintained in functional language, and we generate native code in any language. This would generally give broad code reuse. So you write for one platform and you can publish on multiples. It would also expose the ability to use native languages, native libraries, and consume them into a functional project. This would also enable the mainstream. So existing programmers can easily add functional programming to their projects, even regardless of what language they're using. Would it be cost effective? So if you're publishing into a native language, it should be interoperable with existing codes. So therefore, you're not really requiring a transition. You're not increasing your project budget because you're not really adding anything new. Should be open source with no dependencies and no bloat. So you don't want to add anything that creates a negative friction toward adopting. You should be able to point it at an existing project in another language, run the compile button, and you should be good to go. Generally, a cross-platform environment requires a smaller team, smaller support, and test. So cheaper. An easier language to learn means less training, and easier test means that you can create more tests, and it should be more stable. And generally, you have a bit of future proofing. So if you have a technology change, you can compile to the new language. So in our case, when Flash and ActionScript crashed and burned, we could just recompile to the new language that we want to use. Or if a new platform exists, so like WebGL moving to WebGPU, well, alter the compile operation and then rerun it out to the new platform. Right. How to make it easy to use. A language like this should be easy to read, should be clean and concise with no boilerplate, roughly a fifth of Java size. Should be easy to start, so we should have familiar syntax, not to functional programmers, but to mainstream programmers. Should require no configurations or dependencies. Should be easy to learn, so we want to make it as simple a syntax and the language as possible. And if you're compiling out to another target language, it might make it easier for you to learn that language. So if I want to learn Kotlin and I publish my existing library and out to Kotlin, now I can compare line to line how those differed. It should be easy to teach, clean, consistent, composable, type safe, immutable, testable, documentable. I also throw in that we should document big O of space and time into functions themselves as part of syntax. Should be easy to choose, should work with whatever you have, should be performant because you're writing native code and you're writing plain old native objects. Should be free and open, no egos or overlords, future-proofed, support native code and libraries. It should be easy to run. So we want a single executable that's turnkey out of the box for typical projects. So say, oh, I want a JavaScript front end with a Java backend, and just compile those out and point them to your existing projects. Should be easy to test. So you're testing in one language and you always expect test. To me, test equals documentation. So that basically your test cases are often instructions on the best way to use or not use a particular function. So being able to bring that into your core documentation, publish that to technical support, etc., is extremely valuable. And also, you'd have uniform reporting of tests across different platforms. Let's see what we have in chat. Lua, which is not a function of the. Yep. There's comments about Lua and its broad usage. Yes, there are these different languages that try to approach this. Like Kotlin is actually actively trying to go across all these systems, but I have reasons to be skeptical. A language feature wish list. So as far as what it should do, a lot of this should be obvious to functional programmers, but the core idea here is to have a feature set that we are now adding to other languages. So adding types or functions as first-class citizens into Java, say, which it doesn't currently do. Anyway, first principles, we should design a language from scratch for purpose. It should be simple as possible. So my ideal starting point is Clojure. I find their syntax to be very elegant, but different people may disagree on what it looks like. It should be easy. So we're adding high-level features to make writing code and managing code easier. We're really looking at the API here and making sure that it works very smoothly and is extremely readable. The data structure. So I believe that anything that we create should be a data structure. Sort of imagine XML or JSON, have your entire language like that. It should be a storage mechanism. It should be parsable, and you should be able to serialize or deserialize on the same data structure. Should be scriptable. Scripting and macro support should be consistent. Simple parsing rules. Everything is a function. Functions are types are functions. There should be in-language documentation and annotations. So none of this bolt-on annotation systems. We should support rich types. Should be type safe. That's one of my criteria. Should have a logical hierarchy. There should be empty values by default. So a map always returns a value regardless of whether the value exists. And it should be legal, and all functions should be able to do that. Type factories, generics without using erasures. Use traits instead of inheritance, have rich constructors that allow for all kinds of different construction methods, serialize and deserialize everything. Rich collections, flexible types, so you can have a list of ints and string, and that's legal. You should have restricted types, so you can say a list of numerics, but not floats. Along with collection contracts, so just put in some code to validate inputs. Should have rich functions, so functions are types. We should native async support, clean overloading, so if I want to overload the plus sign, I can. Support for parallelism, variable arguments, unsafe annotations, so we can mark functions as unsafe, so we can allow for ugly behaviors in them. And I'll throw in function level permissions, so that in order to actually run this function, you have to have permissions in your context, like, oh, I don't want to allow people to just delete my hard drive. Should be sturdy, no null pointer exceptions, consistent error handling, don't allow memory leaks, including on C++, protection against infinite loops, basically putting a limit to the number of iterations or passing a limit to the iterations. Should be flexible, should allow mutables in native code or object-oriented programming if needed, with native hooks and code behind. So many projects kind of get stuck in the functional environment where they don't know how to support a function, or maybe it doesn't support that function. The ability to just hack it in and get the job done is a crucial feature in actual work development. It's not something you want, but sometimes it's something you need. A pluggable framework. So if we're using traits, we should be able to have pluggable UIs, event handler, state, load balancing, authentication, context management, IO, database, new stuff, AR, VR, and should be able to operate as a DSL. So HTML, CSS, etc. Should be supported. Okay, I have a couple of questions. All right. Who could benefit? I would say if we are moving toward a single language that we can communicate with, the functional programming language is the first beneficiary. As I said, like a conference like this has so many different languages involved, and in many cases they're so different that having a talk about one doesn't really tell you anything, because if I don't know Erlang or I don't know Haskell, suddenly I can't have a conversation. Students, so easier to learn, making other languages easier. So if there is a language that's actually easier than Java or JavaScript or C++, then students will learn it. And perhaps it will allow them to learn C++ easier. Personally, I hate C++, but I now can write C++ without having to worry about it. If it's easier to learn, there will be more of us. It will help educators. Generally, an easier language is easier to teach. Functional language is easier to teach. It's easier to review. Your test cases can be built with your code. For academics, simple common language would allow them to have more broad reach of academic papers. For developers, it's easier to level up in different languages. Testers, it's easier to identify and read test cases if it's a clean, readable language, especially if you're going across multiple platforms. Technical support, same thing. Visibility into code coverage and test scenarios is generally better for anybody. Architects are more free to use different languages up and down the stack. So if you want to replace some code and you decide you want to move from Node.js to Java on the back end, that's not a nightmare. Implementation teams have easier to read documentable things. Project managers can potentially review code for their customers. They can test progress across the stack. And they don't need to know the nitty-gritty of a particular language and how generics work or something under it. For recruiters, you have a bigger pool of programmers who can actually code in your language. For people who have the money and make these projects and pay for them, they would have simpler functional features, which should bring better ROI. So even if your platform is C#, if you're writing functional code on it, you should have better ROI than you did writing native C# code directly. For the industry, the vendor lock-in harms the entire industry. There are other solutions. I mentioned Kotlin before, but I don't believe that they can succeed at this because their competitors will never support them. So yes, Google will want to do this, but Apple will have some say in that. Microsoft will have some say in that. They don't really want Kotlin to take over. All right. So the end goal. I dream of a time when we all speak the same language. We don't concern ourselves with what the operating system is, whether we're working on client or server, or we're doing app development. It's all the same. I hope that our discussions become relevant to larger audiences. We can better facilitate communication and test. Our libraries are multi-platform by default and somewhat future-proofed. Maybe one day functional programming will become the dominant style. So this is my interpretation, of course. Other people can think what they want. Perhaps this is feasible. Perhaps it is not feasible. Are there other alternatives? I'm sure there are. Is this the time for change, or is there a different time? I see this as a window of opportunity. And what happens if we don't act? We do see the steamroller of AI coding and this broad division of platforms. That's what I see. So generally, I've said my piece, and I'm open to other people's opinions on these things. Following on, I have a number of samples of kind of some more specifics of what I'm talking about, but this is the core of what I'm trying to get across. Okay, so what do I think about language? So I'm not saying this as an abstract. I do have a project of my own, which I don't consider to be a production language, but it is a reference language. It's sort of modeled on Clojure, and then I added type safety and tried to simplify wherever possible. So I currently compile to JavaScript, Java, C#, C++, and Kotlin, and I'm working on the Swift implementation with a few projects, sub-projects under it for different core components. It's written in Go and published as native code, and the test suites all line up. They produce the same output. They produce, actually, the test suite is produced in the application. Anyway, syntactically, it looks something like this. So here is a type and a function. So the type definition is a struct. See two properties, first name and last name. I use the colon as a keyword, so like Clojure does. So which happens to line up with some common syntax for type declarations in other languages as well. And the colon is basically the same as a map under, say, JSON, where the colon would be after the keyword. Down below, have type, which is a person map, a map type, which allows person. The types can be multiple, so I could add as many as I want to. I have a function, which is full name. In this case, I'm using parts of this. You notice also that I have a test case built into code. So writing test cases within the function itself in order to make sure that if I copy and paste out of that function, then I'm also copying and pasting the test suite along with it. See. All right, question. One of the reasons there are all this language investment for walled gardens is the value proposition for actually making money with proposal. What's the business model for such a language that makes sense for those developing language and its implementations? The the core thing is you have this language investment in a walled garden. So if we're talking about a Kotlin environment that you're writing for an Android app, this language would write Kotlin code and inject it. So the real question for value becomes, does the simplicity offset what you would be doing? So imagine the amount of Kotlin code you'd be writing to write a person object, and how much vertical that requires, where you could write this person object like this and publish it out, complete with all of the interfaces and all of the getters, and written as an immutable instead of a mutable object in an object-oriented framework. And then you could integrate with that Kotlin code all you wanted. So it just becomes another feature that is on top of your existing code. All right. When you talk about language features, what does that mean to you? Does this mean some syntax support all these features, or just some answer to these problems? This seems to appeal to some future versions. So this feature list to me is an attempt to project functional goals onto other languages. So to some extent, like everything that we do in a functional language could be done in C. It could, you could pass functions around, like, you have all of these kind of things just by pointer manipulation. But these actually become harder if you start working in, say, Java, where functions aren't first-class citizens, etc. So this is an effort to actually be able to write code where you can write these things, and it will create the code that will actually do the things that we're used to in a functional environment. So therefore, you can pass the full name function as a variable and put it as a property under an object, and take it as a variable and then execute it as a variable. And I'll get to an example of that. First, I'll hit this question. What's your opinion on Haskell as a language to learn FP? I'm not sure. I mean, I don't consider Haskell to be super readable. I generally consider most languages, especially functional languages, to be very unreadable. Haskell, to me, has had its heyday. It could certainly be adopted, but I don't feel that I feel like its popularity is waning and has run into some problems. But I'm certainly not a Haskell guy. I couldn't tell you a lot about Haskell. Is this more an appeal to better syntax, better library semantics, or just better, more portable language implementation? All of the above. So I believe that, first of all, syntax is everything. Like, I despise Lisp's use of like def in order to make declarations. Like, that's so vague to me in a modern world. It would put me off instantly. And it becomes just an obstacle to learning. It becomes like, learn our paradigm, otherwise you can't play in our sandbox. I would like to have everything be designed purely from a simplicity perspective, and then allowing feature set and semantics. And portability, of course, is the end goal. Like, all of this stuff, if you're making something that can't actually work, there's no point. So being able to publish these out so that, okay, I can write very simplistic code and then publish it out to other functional programming languages or whatever I have. It shouldn't really matter, as long as I'm taking a clean, logical subset and making sure that it's going to be something that is something that's represented across different platforms. Generally, I'm not looking to increase feature set. I mean, functional programming has this bunch of stuff that it does well. What my goal is to say that we need a solution that provides better reach. So, if we decide that Haskell is the best thing ever, and it has a really popular syntax that all normies are going to pick up, then great. Then let's use that and then publish that out to other languages. But it has to have reach. Otherwise, we're still in the same bucket we're in now. Let's see. So ticking down time. So I'm going to go through some more examples here. New and copy. So here's an example. So this test function is basically the first value is expected. The second value is actual. So therefore, a string constructor here takes A and B and then just concatenates it. Concatenation is automatic in the constructor. We have a new here, which is there's actually a new function which takes a generic. So it's a generic string list producing ABC. These two things are identical. Really, this string list function is a syntactic sugar. Copy, so everything's clonable. Take a string map, add another name value pair to it. If then switch statements, basically some simple syntax where we convert a common concept that other languages would know into a concept that we understand. And then, note the type we're using generics for returning from our switch statement. Let statement, just to see how variable assignment would work. The colon equals is the notation that I chose. Seems to be consistent with other people's usage. This is actually kind of a familiar pattern for imperative programmers. An asynchronous let. This one's a little cute behavior where this response from HTTP GET is producing an asynchronous value, and then we're passing it directly into an execution. And it's automatically doing the chaining and the future continuations. The only thing that we have to do is add an async annotation onto the function, and then it will do all that work for us transparently. Using a function as a variable, so func var is of type plus, and we assign the plus operator to it, or function to it, and then we execute that.
Randall, sorry for interrupting. I think we need to wrap up. We're running out of time.
Okay.
But thank you very much for sharing your expertise with us today. This session is over, Randall. If you could please head over to your table in the Hangout area, we can continue.